In this demo, we'll be discussing what REST or REST APIs are, and then we'll review how to use the Open Automation Software REST API for accessing data or for configuring the OAS service itself. REST or REST APIs are methods of exposing data and operations for automation or even custom user interface development. In that way, it's no different than any other API, except the technologies that REST is built upon are ubiquitous, namely HTTP and JSON. So adoption of REST APIs is fairly easy. So what exactly is it? REST stands for Representational State Transfer. REST APIs are designed to mimic database or resource operations, so they dovetail nicely into many application architectures. These operations are collectively and affectionately described as CRUD, or Create, Read, Update, and Delete. In database terms, these are Insert, Select, Update, and Delete, and used to create or manipulate object records. Since the HTTP spec has parallel methods, post, get, put, and delete, it's a natural fit for building operations that can be tied into individual URLs. For example, if you wanted to expose a list of books in a library API, you could create a URL such as myserver.com/library/books. Any client could issue an HTTP GET on that URL, and it would list all of the books in the library. If you wanted to retrieve a single book record, you could issue an HTTP GET to a URL such as myserver.com/library/books/the ID. In this example, 12345 is the ID. So each resource has its own URL, as well as operations such as selecting a whole collection. To create a new book entry in the database, a client would issue an HTTP post to myserver.com/library/books. But in this case, the body of the message would contain the data that would represent the book record being inserted into a database or other system. Traditionally, a REST API would then return a response that indicates the new ID or a unique identity for the database that has been assigned to that new record, so that you can then use it in a request such as the one that we've seen before, where you would list the /library/books/ID of the record you want to retrieve. Now, to update a book record, you would use HTTP put on the same URL as the individual book. So again, you would just use the same URL of the resource, /library/books/ID, and then you would issue a put with the body containing the contents of the record being updated. And finally, deleting a record is issuing an HTTP delete to the URL of the resource. But these are all just conventions, since there's no protocol definition for REST APIs. Nor is there any requirement for any specific data format for each record. So for an API to be considered RESTful, it really only needs to be a stateless transfer of data over HTTP, using the HTTP methods to indicate the desired action. This means you can encounter a wide variety of REST API implementations using many different forms of data, including XML. But today, general convention is to use JSON as the data format in a REST API, and for very good reason. JSON stands for JavaScript Object Notation. And the major advantage of JSON over XML or some other data formats is because JSON is just JavaScript, all browser and script engines natively understand and can parse it. It's very human readable, using simple yet hierarchical key value pair notation, and it can still represent objects, rich objects, arrays, and multiple data types. But the biggest advantage is while remaining human readable, it is much more efficient than XML, since the notation is lightweight. In this example, you can see the difference between an XML list of books and a JSON list of books, and you can see how the same data is represented, but there's much less notation around the raw data itself. So imagine this being used over and over and over again. The cost savings just in bandwidth and data transfer are enormous. So when would you use a REST API? More specifically, when would you use the OAS REST API? Open Automation Software has always provided many ways of reading and writing data, including native device drivers, tools for both .NET and Web HMI development, as well as .NET components for programmatic reading and writing of data, even programmatic configuration of the OAS server itself. But the REST API exposes these same capabilities to any platform that can support JSON over HTTP. This opens up integration scenarios such as creating data sources from IoT devices like Arduino, Raspberry Pi, integration with other Linux computers, integration with Java applications, code written in Node.js running on any platform, or even developing custom HMIs on any platform. Using the REST API, you can even automate OAS server configuration, and again, from any platform that supports HTTP and JSON. So now we're going to take a more detailed look into the OAS REST API using two different clients. One is the web REST client using HTML and JavaScript, and the other is a .NET or WPF REST client, and it's written in C#. This will give you an idea of how you can use different languages and different tools to do pretty much the same thing. Hit the REST API with JSON over HTTP. And you can also download the full source code at openautomationsoftware.com/knowledgebase/example source code. Just scroll to the bottom and you'll see both of those clients, the web REST client and the WPF REST client. The first step before using the OAS REST API on your own installation, you need to start the OAS service control. Make sure that all the services are stopped, and then click Register on the HTML HMI or Web HMI registration. This will start the HTTP listener on the configured port. By default, it's 58725. Once the registration is complete, you'll be asked if you want to start the services. Make sure that you start all of the services, including the OAS Framework 4.5. That's the service that houses the REST API itself. Once that's complete, we can start looking at code. Throughout this demo, I'm going to be referencing the online REST API Explorer. This can be found at openautomationsoftware.com/REST API. This is both online documentation as well as what's called a test harness. It allows you to execute actual calls against the REST API that's running on a remote server. It could be the demo server that we've got that runs by default, or it could be your own server. All you have to do is change the host and port on the REST API Explorer, and you can use this tool to execute against your own installation. So a few things about the documentation. You'll notice that there's a note here that's very important. All operations require an authenticated session. Well, that is, except for the authentication method itself. This will give you a client ID and a token. These are unique identifiers that identify the session and the credential that's being used by the session. So in this documentation, you can scroll through and see all the different operations, and on the right-hand side are examples of the objects that you can send over to each one of the operations. So this first operation that we're going to execute is authenticate. This requires a username and password object to be sent in. Response code is 401, which means unauthenticated, and you'll even see that in the message on the response it says default credential provided. If your server is not configured to allow default credentials, you'll get a 401 authentication error and you won't be given a client ID and token. So let's copy this off and save this so that we can use this in our subsequent operations. Now that we've got these credentials, we can execute all the other operations in the API. And in this case, I'm going to go select the tags, and we'll get a list of tags from the server. So we'll put the client ID and token in the required fields. Now there are other fields in this operation. You'll notice you can read the documentation on what they do, but by default we'll just get the base information at the root of the server. So we'll click try, and just like the authentication operation, you'll see the response come back. And in this case, now we have an array of tags. Each one of these tag objects has the tag name, which is the path, the value, and the timestamp. So let's explore how to perform these very same operations using the REST client sample code. So I'll open up the client code for the web, and it's fairly simple. There are three files. There's the client CSS, the client JS, and the index.html. The HTML file has all of the fields and references to the others, including a reference to jQuery, which is required. But it's only required for this sample. It's not required for the API itself. So you'll see that the CSS just has some styling for making the page look a little bit nicer. The JS is where you'll see all of the execution happening. And the HTML just houses the fields for collecting input from the user. We have a field for the server that we're going to be connecting to, and by default we're going to be using the demo server. We also have fields for the path, which is the URL that we want to hit. We'll choose the method. These are HTTP methods: get, post, put, and delete. Then we have the client ID and token that we're going to be inserting for each one of these operations. And the data itself, this is the body of the message that we're going to send up to the server. So let's jump over to the JavaScript so that we can see where the calls are actually executed. So you see at the top we've got a server variable being set, so that's our default server. And then the API base. This is the rest of the URL that goes to the REST API. And all the action happens within this make call function. So at the very top you see we're collecting all of the input data from the fields. And then we just do a quick check to clean up the input data. So if it's a JSON formatted object, we just format it, clean it up to make it look a little bit nicer. And then we use the jQuery AJAX call. This is an asynchronous call up to the server itself. We make sure that the content type is application JSON with a char set of UTF-8. And then we make sure that it says cross-domain. This allows us to execute from different clients and servers. Then the data type itself is JSON, and then we pass the data, whatever the data is we're sending in. You see here we've got a headers section. This is where the client ID and token are sent. That's part of the specification of the API. So then when the execution is complete, we set the HTTP status in the status field, and then we put the response, the raw response data, we parse it into a JSON object, and then we clean it up and then display it in the response field. Because this is a web application, we'll want to host this in a web server. It's not written to be specific to any web application server, but we'll install it in IIS for this example. So we open up the IIS manager, and we're going to go to my default website here. This is just the website that's installed on my local machine. I'm going to add a virtual directory. We're going to call it REST Client, and we're going to point this to the folder where I've got the application source code. Create this virtual directory, and then once that's up and running, we can just use our browser and connect right to it. So we go to localhost / REST client, and we'll see the application start right up. So as we saw before in the source code, we've got our server, our path, the method, client ID, and token. We're going to execute the authenticate method as we did in the API Explorer. This is a post method, and we're going to give it the same username and password, which are blank. You have to format the data as JSON. We'll execute that, and you see we get the same response from the server. 401 unauthorized. Again, that's because it's the default credential, but we still get a client ID and token. Now we can take that client ID, put it in the client ID field, put the token in the token field, and we're going to execute now the tags. This is a get request, so we have to change the method to get. We're going to remove the data because it's a get. We don't need body data. Execute that, and we see we get 200 OK and the same data coming back. So now let's jump back over to the REST API Explorer, and we're going to do something new. We're going to create a tag list to monitor. This is a unique list of tags that will be given an ID, and then once we request that tag list, it will then just give the data just for those specific tags. This is useful for getting real-time data and polling the server. So the URL is tag lists. It's a post, so we have to create this tag list, use the same client ID and token, and now in this tag list, we're going to list an array of tags. So you see here we've got an array, which is denoted by the square brackets. And then we're going to, within the tags array, create an array of objects. And the objects are the curly braces. And this is going to have a single key value pair. The path, and then the value is the tag name that we're going to monitor. In this case, it's going to be sign value. I'll replicate this a few times because we'll get a few different tags, and we'll just change this to pump value, that's Boolean. And then we'll also grab the random value, which is just a random integer. So when we execute against the server, it will say create complete. That means that it created a tag list in the server to monitor, and it gave it an ID. So now when we put in the tag list /ID using the get, it will tell the server, give me the current values for that tag list. We'll get rid of the body again because this is a get request. and then execute that, and we'll see that's the current data for those tags. So we can now, using the client ID and token, just keep requesting that data, keep polling against that data to get updated values. And as you probably guessed when we were looking at the REST API Explorer, if you've done that on your own, you can update that tag list by using the put method, and you can delete the tag list from the server to have it stop monitoring those tags using the delete on that same ID. So let's open up Visual Studio now, and we'll do the same exact thing using the WPF client example. First thing you'll notice is the user interface is almost the same as the web example. We've got the server field, path field, the method, client, token, and the data. We also have a field for response status and the response body itself. And in the code, even though it's written in C#, it uses the same logic or the same relative flow. We have a make call function, and this uses the HTTP client built into .NET, and we set up the base address. We do the same kind of formatting, and in this case I'm using an open source library from Newtonsoft. You can get that through NuGet, or you can download that directly from Newtonsoft's website. This is great for JSON formatting and creating objects and serializing and deserializing data back and forth between JSON and text. So we clean up some of that JSON data, we parse the string and then format it. We set the header of the HTTP request to application JSON. If there's a client ID or token that's set up in this request in the user interface, we apply those to the headers as well. And then here we have a switch statement because we have to use different asynchronous methods on the HTTP client based on whether it's a get, a post, a put, or a delete. Once that completes, we get the response, parse that back into JSON, and then we display that in the status field and the response field, just like the user interface on the web application. So we're going to do that authenticate method again, using the same exact user identification. So we'll use a username that's blank and a password that's blank. Again, this is going to return a 401 saying that it's unauthorized, but that's only because it's not a real credential, it's the default credential. But it gives us the client ID and the token that we can use for all the subsequent requests. So now we're going to change this into a get. We'll use that tags URL, and we'll fire that off. So there's one more tool we want to show you, and that is Postman. Now this is a Chrome extension. This is not written by Open Automation Software. This is a free extension that you can get and add it onto Chrome. It's very useful for testing out APIs and working on projects where you're doing multiple requests against servers and you want to save those results or save those tests in a bundle. So I'm going to go into my extensions in my browser, and at the very bottom you can see that it says Get More Extensions. So I'll click on that and we'll go to the Chrome Web Store. We'll search for Postman, and you'll see under apps there's the app called Postman. You can add that to Chrome, and once that's complete, it's in your app launcher now. So it's a separate app, but it's just launched from Chrome. So this brings up a user interface that lets you create an account. Now you don't have to create an account to use it, but if you do create an account, it will save all of your settings, all of your tests, and it'll help you when you're working on large projects. So we'll hit our OAS API using Postman. So in this case, we'll do an authentication. We'll go back, and now we're going to create the full URL. This is HTTPS for the demo server. It's oashmi.com, port 58726. And the rest of the URL is OAS REST /v2/authenticate, where authenticate is the operation we're going to execute. We're not adding anything to the header at this point, but that's where you would put the client ID and token. And in this case, we're going to put raw data in the body of the message. And this raw data is the JSON that we're going to send. So the same JSON that we sent in our previous test. So username blank, password blank. Now if we were to execute this right now, you'll see what happens. We're getting an error. It says the incoming message has an unexpected format of raw. That's because we need to tell this client that it's going to be sending up JSON formatted data. We'll re-execute that, and now we get the same results we were getting before. Client ID and token has been assigned to this session. So we take that client ID and token, just as we did before, and now we're going to put those in the header of the Postman requests for these new operations. So we're going to create a new operation here in a new tab, give it the URL for tags, put in the header the client ID and the token as a separate field. So now when we execute the request, we immediately see there's an error. Now why is that? That's because I made a mistake and forgot to put the port number in the URL of the address. But what you see in the error is it's a 404. The URL is not, or the resource is not found, which is what you'd expect if you gave it the wrong URL. So now we give it the right URL with the proper port number, and you see the data coming across just as we expected. For more information about Open Automation Software or the OAS REST API, go to openautomationsoftware.com/products/HMI SCADA for web/REST API. To download the web and WPF REST clients, you go to openautomationsoftware.com/knowledgebase/example source code. And for more information on REST in general, you can check out the Wikipedia entry, wikipedia.org/wiki/representational state transfer.